Welcome to Future Doctor NEET Academy for the problem solving session in NEET. The topic chosen today is from chapter 12, atoms. Let's move to question number 1. For which one of the following Bohr model is not valid? Actually, Bohr atom model is valid for hydrogen, helium like atoms only. Okay, hydrogen, protium, deuterium, tritium, helium atoms only. So your correct option is C. Yes. Option C, simply ionized neon atom is not valid. Let's move to question number 2. The total energy of an electron in an atom in an orbit is minus 3.4 eV. Total energy is given minus 3.4 eV. Its kinetic and potential energies are dash. Actual formula is total energy E equal to minus RHC by N square. And this is only given as minus 3.4 eV. Minus 3.4 eV. Okay. Now, kinetic and potential energy. Kinetic energy K equal to, formula is RHC by N square, and potential energy U equal to minus 2 RHC divided by N square. Okay, now total energy, but you want to find kinetic energy only. So kinetic energy by total energy, K by total energy equal to minus RHC by N square. No, this is plus, no, yes, this is plus. Plus RHC by N square into total energy is minus RHC N square. Now this N square, these and all getting cancelled. N square, RHC equal to, just we will get minus 1 only, equal to minus 1. So kinetic energy by total energy equal to minus 1. Then kinetic energy equal to minus of total energy. Total energy is given minus 3.4 eV. So minus of minus plus 3.4 eV. This is kinetic energy. Next come for potential energy. Potential energy U by T. U by total energy. Okay. U is minus 2 RHC divided by N square into, this is minus RHC by N square. Is it so? That is the total energy. N square. Cancel this N square getting cancelled. RHC getting cancelled. Minus getting cancelled. Minus getting cancelled. Then U equal to 2 times of total energy. Total energy is given already as minus 3.4 eV. So 2 into minus 3.4 eV. That is equal to minus 6.8 eV. Okay, so which option? Kinetic energy 3.4 eV and potential energy U equal to 6.8 eV. Option B is the correct answer. Let's move to question number 3. Ratio of total energy of the kinetic energy to the kinetic energy of an electron in the Bohr orbit of the hydrogen atom is dash. Kinetic energy equal to formula RHC by N square. Total energy minus RHC by N square. Here you want to find total energy by kinetic energy. So total energy is TE by kinetic energy K. Then that is equal to, what's the formula? Total energy is minus RHC by N square into RHC by N square. Now cancel things. N square getting cancelled. RHC getting cancelled. So what's the answer? Minus 1. Minus 1 by 1 or 1 is to 1. That is option B is the correct answer. Let's move to question number 4. Proton and an alpha particle both enter a region of uniform magnetic field B, moving at right angles to the field B. The radius of circular orbit for both the particles is equal, and the kinetic energy acquired by proton is 1 MeV. Then the energy acquired by the alpha particle will be dash. Formula is E equal to E square B square R square by 2M. It's a simplified final formula. Then here what's the this thing E depends upon? E depends upon 2 factor only. E is proportional to E square and inversely proportional to M. Okay. Now 2 particle is given. One is proton, another one alpha particle. So for proton we'll keep E1, small e1, M1, and E2 equal to, E is proportional to E2 square by M2 square. Now here what you want to find? You want to find energy acquired by the alpha particle will be. So E2 by E1. Is it so? It's not E1 by E2, E2 by E1. Then E2 by E1 equal to, E2 is E2 square by M2 into E1 is E1 square by M1. Then that is equal to, E2 is the charge of the alpha particle. Alpha particle is Hc24. Proton is H11. This is Z and that is mass. Okay, actual formula is X Z2M. This is the formula. Okay, for hydrogen, this is for helium. Then substitute this here. We will write down. E2 by E1 equal to, E2 is how much? That's alpha particle charge, 2E, and its mass is 4m. 2e whole square, this is 2e whole square into this, and charge of proton is 1 square, that is E square by M square. Then it gives 4e square by 4m into, not m square, this is just m, 2e square into m, no, e square is E square, m getting cancelled, then into m by E square. Now 4 getting cancelled, E square getting cancelled, M getting cancelled. So equal to 1 only, equal to 1. Then E2 by E1 equal to 1. E2 equal to 1 into E1. E1 is 1 MeV is given. So 1 MeV. Which option? Option D is the correct answer. Let's move to question number 5. Ratio of the longest wavelength corresponding to Lyman and Balmer series in hydrogen spectrum is dash. Lyman series means, what's the formula for Lyman? For Lyman series, formula is, we'll keep this as wavelength lambda 1. 1 by lambda 1 equal to R into 1 by N1 square. N1 square is 1. 1 square minus 1 by 2 square. Okay, that is equal to 4. 4 means 3R by 4. 3R by 4. This is 1 by lambda 1. Okay, and similarly for Balmer series. For that, 1 by lambda 2 equal to R into 1 by 2 square minus 1 by 3 square. Okay, 1 by 3 square. Then 1 by lambda 2 equal to 5R by 36 on simplification. Okay, 9, 4, 36 on simplification we are getting this. Now the question is ratio of longest wavelength corresponding to Lyman to Balmer. So lambda 1 by lambda 2 we want to simplify. Okay, then lambda 1 by lambda 2 equal to, lambda 1 by lambda 2 means 4 by 3R into lambda 2 is 36 by 5R. Simplify this. 4, 9, 36. R getting cancelled. Then 5 by 9, 3, 27. So lambda 1 by lambda 2 equal to yes, 5 by 27. Which option? Option A. Option A is the correct answer. Let's move to question number 6. The energy of a hydrogen atom in the ground state is minus 13.6 eV. The energy of the helium ion in the first excited state will be dash. That is for helium atom. For helium atom means Z equal to, already we discussed, He24. So Z equal to 2 and mass only 4. And first excited state. First excited state means N equal to 1, 2, 3, 4, etc. N equal to 1 is a ground state. N equal to 2 only first excited state. Okay, then substitute. Then E N equal to 2. N equal to 2 we mentioned. Equal to minus 13.6. What's the value of Z? 2. So into 2 square by, what's the value of N? That also 2 square. 2 square. Then 2 square getting cancelled. Then what's the value of E2? E2 equal to minus 13.6. And this is in EV. It's already in EV only, electron volt. Option A is the correct answer. Let's move to last question. When electron jump from N equal to 4 to N equal to 2 orbit, we get dash. That is, N equal to 2 means that is Balmer series only from N equal to 4. So N equal to 4 is the second line. N equal to 3, first line. N equal to 4, second line. What's the formula for the Balmer series? That is 1 by lambda 1 equal to R into 1 by N1 square is 2 square minus 1 by N2 square is 4 square. Okay, this is the formula for second line of Balmer series. So option B is the correct answer. Okay, thank you students. In next session, we will see problem solving session in next chapter. Thank you.